So the next question is trapping rainwater. Let's read the question. Given in non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay. So basically what it is saying is that you will be given an array of size n where all the elements are non-negative integers. Okay, and they will be representing the values of this array will be representing the height of bars, and within those bars how much water can it trap. We have to figure that out. We have to return that as the output, like how much water is getting holded in between the bars. Okay, so I have copied this thing over here. Okay, and I have written the values over here. So let's go ahead and check. Obviously the output will be 6. How is it 6? Over here you can see that over this first tower I can like there is 0th tower, there is no bar, so I will consider this there is a bar of height 0, right? Over this I am not holding any water, because if I hold any amount of water over here it will overflow in this direction, right? So we are not holding any water on this side. Next, there is this bar over here on index 1, where obviously we cannot hold any water over this bar as well, because it will overflow to this direction, right? So that's why there is no bar in this, there is no water on the bar at index 1 as well, right? After that, in the second tower, in the tower at index 2, it is a tower of height 0. We can see that we can hold 1 unit of water over here, right? We can hold 1 unit of water over here. Next, over here also same thing. If I store any water in the tower at index 3, it will overflow towards the left, so we don't accommodate any amount of water over there. Over here in this cavity you can see this is the second unit of water, third unit of water, fourth unit of water, and fifth unit of water is also there. And over here also you can see it will overflow, so no water over this tower. If I hold any tower over any water over here, it will go all the way and overflow in this direction, so I cannot hold any water over here, right? After that, here there is another unit of water that is getting stored, because it is been bounded by two towers of height 2, right? And this water is standing on a tower of height 1, so we can hold only 1 unit of water. I hope this is clear how the output of this particular given input array is 6. I hope this is clear. Now, talking about the logic, we'll be discussing two approaches. One is the better approach and the other one is the optimal approach. So let's start with what can be the logic of how we are holding the water, guys. Let's talk about the logic. See, what I am saying is that on this tower over here, or on this tower, or on this tower, or this tower, or this tower, or this tower, there are no water above these towers. And also, if you consider this as a tower of height 0, there is no water on this tower. Then the question is why? Because if you look carefully, observe the pattern carefully, you can see that for all other towers there is a bounding maximum towards the right as well as left. And the towers that I have marked right now, those towers, they don't have either a bigger tower on the left, or they don't have a bigger tower on the right, or both. If you observe carefully, this tower over here on index 0, it has a bigger tower to it on the right, but it does not have any tower towards its left. So we can say that the first tower and the last tower, they won't hold any water above it, because they will overflow on the sides, right? So always, whichever array is given to us, whichever height of the bars are given to us, those bars won't be, the first bar and the last bar won't be accommodating any water above it. And also, let me just quickly give you the intuition. You have to view, the intuition is very simple. You can figure out the solution if you try to view tower wise. Like if you want to find the answer tower wise, like if you take each tower individually, then how much water is each tower holding above it? If you try to observe it in this manner and try to identify a pattern, then only you will be able to solve it. That is the intuition. Like you have to find the answer tower by tower. That is the intuition, guys. So what I was saying is that the first tower and last tower will not hold any water above it. Now next to that, I am talking about this tower. This tower also does not hold any water above it, because the logic that I have said, it has a bigger tower to its right, but there are no bigger towers towards the left. This is of height 1, and towards the left the maximum possible height is 0. So basically this tower does not have a bigger tower towards its left. So that's why no water will be holded in this tower as well, above this tower. So first way I have covered. Then look at this tower at index 3. Towards its right, I can see that there is a tower which is bigger than it, but towards its left there are no towers that are bigger than it. So here also there is no water above this tower, right? After that, if I talk about this tower, you can see that obviously there are maximum towards, there is a bigger tower towards its left, also a bigger tower towards its right. So basically this tower can hold water above it, and it is holding some water above it. Okay, we'll be coming to this later. Let's observe for all the other towers. See, this tower over here does not have a bigger tower towards the left or towards its right. This tower over here, it has a bigger tower towards its left, but no bigger tower towards its right. So basically we don't allow holding of any water into it, right, above it. After that, this tower over here, it has a left and right maximum, so we hold water above it. We're coming to this later. And after that, this tower over here, this tower is also not holding any water above it, because towards its right there is no bigger tower, and same for this, does not have a tower towards its right, and also it is the last tower, tower or bar, whatever you call it. Now coming to the towers which are holding water above it, how much water can it hold? Like, we have to find out that how much water it can hold, right? If you try to look at that, how much tower, so if I talk about this tower over here, it is holding some water. So what I am saying is that towards its left, the maximum possible tower is, the maximum height tower is of height 2, this one, right? And towards its right, there is, towards its left, it is a tower of height 2, and towards its right, the maximum is a tower of height 3. Now obviously guys, on this tower over here, I cannot hold 3 units of water, because if I hold 3 units, it will overflow towards the left, because towards the left the maximum that is possible is of height 2. It can hold up till height 2 only. Now this thing, I hope it is clear that whenever I have a left max and a right max for a particular tower, that particular tower can hold water up to height which is the minimum of both of them, not the maximum. So whichever is the minimum among left max and right max, over there only water can, up till that height only water can get hold. But obviously the minimum height is 2, but we can hold only a water of 1 unit over here. Why? Because the tower itself is taking up 1 unit of space. So maximum that I can accommodate on this tower over here is 2 units of water. Maximum this I can accommodate, because towards the left and right the minimum is 2. Now if that particular tower is only occupying 1 unit of height, then the rest left 1 unit of water only I can hold over that. So for this tower I would add only 1 to my answer. I hope the logic is clear, that when can a tower not hold water above it, and how much can a tower hold if it can hold, right? Let's check for another one example. Suppose this over here, this tower over here, tower of height 0 I can say, towards its left the maximum is 2, towards its right the maximum is 3. So obviously the minimum among them is 2. I can hold a maximum of height 2, but obviously the height, we need to subtract the height of the bar as well. The height of the bar is 0, so it is basically maximum allowed is 2, minus 0 is 2, so it is holding 2 units of water. Let's also check for this over here, this tower over here. Towards its left the maximum is 1, towards its right the maximum is 2. The minimum among them is 1, and thus this can hold a maximum of 1 unit of water. The bar itself is of height 0, so 1 minus 0, 1 unit of water I can hold. So the formula that is coming up is, my answer must always be incremented. My answer must always be incremented for each tower. If I am at index I, for example, then my answer would be incremented by math.mean of, if I have account of the left maximum as well as the right maximum, then I can pick out the minimum among these two, and with that whatever the minimum is, that is the maximum allowed water in that particular, on that particular index. But I have to subtract the height. If suppose the height, the array that is given to us is of name height of I, we need to subtract whatever the height that is already the tower is occupying, that much water we cannot hold, rest of it we can accommodate with water. Next, one visualization that I want you to have is this value over here, this can never run negative. Why? Because have a simple observation. Suppose observe this tower over here, towards its left, like up till here, the left maximum is this tower only, which is of height 2, the L max is 2, and towards its right, the maximum is this tower over here, which is of height 3. So for this tower, when you are computing how much you will add to answer, you should add 0 to the answer, because on this tower there is no water. So there should not be a negative value that should be added to the answer. That is our agenda. So now what I am saying is, towards its left the maximum is 2, towards the right the maximum is 3, and the tower itself is of height 2, so minus will be 2. So you can see the whichever will be the minimum among these two, if that tower is the maximum until there, then its height is only the maximum, and with that maximum height we will be subtracting that maximum height only, because that tower is the maximum until then. So in worst case you will get a value of 0 over here, and that is what should be added for this tower, because this tower over here is not holding any water above it. It should have like with the answer 0 should be added, and that is what is happening. This value will never run negative. This is the visualization. Think over it, right? Next, if this is the logic, I hope this is the logic on which tower we can hold water and on which tower we cannot hold, how much we can hold. This formula will be generalizing all of the towers. So guys, using this approach, I have told you the intuition about how we can calculate the towers, but implementing this approach, there can be multiple methods to it. There can be an order of n square, where for example basically what you are doing is, you are traveling, your I loop is traveling from I equals to 0 to all the way till n, and like less than n, up till where the indices run. After that, for inside this you can take a j loop which will run from 0 to I, for example, and over here you will calculate L max, right? And after that you will also run a loop k, for example, which will run from I to n minus 1, and you will be basically calculating your R max, and then for each of this tower you will be calculating which one is the minimum of L max and R max. Minimum of L max and R max you will calculate, and then you will add that to the answer, right? Add that to answer, right? I hope this point is clear. I have written as pseudocode answer plus equals to your this value over here, right? So this is what you will do. For each iteration, for each tower you will travel all the towers in towards its left, including that tower, and try to find out the left max. And also from I plus 1 I should do, from I plus 1 to the last part of the array we need to find out what is the maximum, and that will be your right max, and find the minimum. So this will be obviously this j and k loop togetherly, they will, for each iteration of loop I, this j and k loop will run togetherly, they will run for n iterations, n number. One is running from 0 to a certain point, and the other is running from that certain point to the last. So it is a whole complete iteration for each iteration of I. So this will be order of n square. This will be of order of n square. But obviously there are better approaches. So the next approach that I will tell you is that where we can solve it in order of n, or rather order of 2n, let us see. And we will also use a space complexity of order of n. Okay. So that approach is what, guys? Let me just copy this array. What we can do is this left max and right max, instead of for each element calculating, iterating through the whole array and calculating them, what I can do is I can make an array out of them. Suppose I am making a right max first, where from the right I will start iterating and store all the right maxes up till this tower over here. The maximum is 1, then it becomes 2, then it stays 2, becomes 3, then it becomes 3 over here, 3 over here, and for the rest of the arrays it will be 3. And each index is basically representing that towards the right of this tower, including this tower itself, what is the maximum towards its right. And then what you can do is you can start iterating from the front and make a take a left max variable and within that variable start storing the left max, right? That is the most optimal way to do, or for explaining purpose I am making the array, but these values what I will be storing over here in this left max, this will be calculated on the fly during the iteration, right? So left max up till here the maximum is 0, then up till here the maximum became 1, then it continued to be 1, then it became 2, 2, 2, 2, and after this point it is all 3s, right? So this is the left maximum. Now what you need to do is you need to again iterate, like while making this L max only, these values will be calculated on fly, and on that iteration only what you can do is you can with your answer you can add whichever is minimum, right max and L max, whichever is minimum, you have to take that math.min of left max and right max, whatever I have written earlier, right max, and that much is the total water capacity, but you have to decrement the height of I. That is what we need to do, and this particular thing will give you the answer. At the end you have to just return this answer. I'll quickly show you this approach, and then we'll be moving to a better approach. Let's see if this particular, you can see that obviously we are taking an space complexity of order of n, but time complexity wise also let us check if this is the better solution or is there a better solution that is available. So if I just go ahead int n equals to, I'll take the heights array, height dot length. After that I'll make a right max array which is equals to the size will be equal to the original given array. After that what I'll do is I'll make my answer variable, answer equals to, I'll assign it with 0, and after that I need to fill this right max array. So basically I'll take a temporary max variable which is I cannot take it rmax because that is the name of the array. So equals to, I'm initializing this with integer dot main value, or also I can initialize this with negative values because negative values are not allowed in the input array, whatever it is. Then I'll iterate through the array from the back, right? I is greater than equals to 0 and I minus minus, and then over here what I need to do is I will start calculating the maximum and fill that in rmax. So my max will be equals to, if I use ternary operator, if max is if height of I is greater than max, then I assign the value of max with height of I, otherwise I assign it with max. I hope this is clear. Now after that I will just fill this rmax of I with this max, right? On the fly I am calculating the max, whatever is the max, and then I am assigning it to the array. Then after that let me just reuse this value only as left max. I am just reassigning it with the min value, and after that I'll start iterating the array from the front for int I equals to 0, I less than n, I plus plus, and on the fly I will calculate this left max. This max will act as left max. So max will, this thing again will be done. Max will pick out the max until now, and I will compare, this value will be considered as left max. So with my answer I will add what? I will add math.min of L max is not there, left max is basically this max, and R max is your right max. Among, we have to pick out, this is the maximum allowed water level, and from this I need to subtract the current height of the building, and then I can find out how much water is accommodated on top of that building, and that particular units of water will be added to my answer array. So after this only I can return my answer. Let's check how fast this is. Okay, okay, rmax is the name of the array, right? So I have to write rmax of I at that particular index. What is the maximum to the right? Okay, cool guys, you can see that it does not beat all 100%. Why? In the run, this is not the memory part, this is the time part, right? So basically we are doing it in linear time. We are just iterating through the array twice, and then also we are able to say that this is not the fastest solution. So immediately what should come to your mind is that, okay, then there is maybe a single iteration solution that is available, because I am doing it in order of n. I cannot do it in order of 1, right? Without knowing the bars only, I cannot do it in order of 1 or order of log n, because there is no sorting thing that is mentioned over here. The bars can be as it like it's, right? it is not sorted or some sort. So basically I have to do it in order of n only. This time we are doing it in double iterations, in 2 iterations, basically order of 2n. We can bring this down to a single iteration maybe. And also in that approach, guys, the space complexity is also going to decrease. It will become order of 1 space complexity. But the entire intuition that whatever must be like above a particular tower, for each tower we need to calculate how much water is above it, that intuition is also same. And also the intuition that whatever is the minimum towards its left and towards its right, that will be taken into consideration, and that will act as the main logic over here as well. But we are going to do it in a single iteration. Okay, so how are we going to do it in single iteration? See, what I'm saying is, let me just copy this thing over here. Okay, now what I'm saying is, this array over here, how can we figure out in linear time? Basically we will be having a 2-pointer approach. One will be my left pointer, which will be starting from the first index, and the other will be the right pointer that will start from the last index. Now I will keep a track of this. Left will basically iterate this way and right will iterate this way, and all on the way I will be having 2 other variables, left max and right max, that will calculate whichever is the running max, like till how much right has traveled, till that much what is the maximum possible tower that is stored in Rmax, and how much till left has traveled from 0 till that much what is the maximum bar that is possible that is stored in Lmax. So we'll be taking these 2 variables as well. Now what I can say is, this tower over here, for the first tower, let's check. Suppose we have an example where there is a tower of height 4 for example, and there is a tower of height 8 for example. Okay, and now I have a tower over here which is of height 2, and we also have a tower over here which is of height 2, right? Now in the middle the towers are unknown, there can be any towers, we have not iterated. Over here, suppose I am just ignoring this edge case, then suppose over here I have registered that Lmax is 4 and my right max is 8. Okay, then suppose my left has moved forward. I need to make a decision which one to move forward. Okay, this is my left and this is my right, so I have to make a decision which one will move, either the left will move or the right will move. So try to figure that out, that if I tell you, if for example left moves over here or right moves over here, now whichever tower it moves to, try to find out for which tower, for this tower or for this tower, you will be able to find out how much water will be above it. Can I guess how much water will be getting stored over here in this tower? The answer is how. If I tell you, if you say that okay, the minimum is 4, so and the height of this tower is 2, so I can accommodate water of height 2. But you might be wrong, because in the middle there might be a bigger tower than 4, and suppose this is of height 6, so in that case you should store water of height 4, because total allowed is 6 and this tower is of height 2, so you can store an additional 4 units of water. So you cannot really tell how much water will be stored above this tower at this point, but you can tell for this tower. You can for sure say that it will hold 2 units of water only, because it cannot hold more, because it will get overflowed, and also there is no possibility of this water getting overflowed to this direction, because I know there is a tower of height 8 which will prevent the overflow. I already know that towards its right there is a bigger tower that is possible. So basically whichever side is having the minimum tower among the Lmax and right max, I should proceed on that direction, and after proceeding you just saw how we can calculate how much water will be left using the same logic. Among the left max and right max, whichever is the minimum, that much amount of water it can hold, because this water will not be affected by any tower in the middle. If there is a smaller tower, then also it might overflow over these smaller towers, and it will ultimately be stopped by this right tower. And if there is a bigger tower of height 6 maybe, then also I cannot accommodate more water, because it will overflow towards the left. I hope the logic is clear, that using these 2 pointers only I can move one place towards the left or towards the right, and calculate on the run only how much water will be stored on a particular tower. And we can do that on the side where the minimum tower lies among left max and right max. So this is the logic, guys. I'll also write this code I'll also write this code. What I'm saying is, the logic is that this much only. Sit over it. If you want to listen to it again, listen to it. But this is the logic. You try to make any case. Try to make any case where if this tower is of height 2 and you have known that there is a tower of height 4 on this side and there is a tower of height 8 this side, and you don't know whatever is there in the middle, then also you can correctly predict that this can hold a max. It can hold 2 units of water only, because towards its left 4 is there, towards its right does not matter if a smaller tower comes or a bigger tower comes, it will still hold 2 units of water only, right? It cannot hold more because it will overflow towards the right, and it will never overflow towards the right because towards the right there is a bigger tower. Cool. Let's write the code for it. What I'm saying is that I will take the size of this array, height dot length. After that I need to take 2 variables, start or end, left, right, whatever you can do, right? Left equals to 0 for example, and right let me take start and end. Let start equals to 0 and end equals to n minus of 1, right? After that I'll also need to take left max, which is equals to, for example, I'll initialize this with integer dot mean value, or I can do it as -1 as well, okay? And also int r max equals to -1, okay? After that I'll start my iteration. After that while my start is less than end, then what I'll do, until they cross each other, what I'll do is I'll need to find, like for example, if I'm standing at my start is pointing to a tower, I should check if that particular tower is becoming the new maximum or not. So we should update both the maximum L max and right max as soon as the iteration starts. So what I'll do is, if my height of start, the current bar that I am staring at with the start variable, if that is greater than my left max, which in any case it should be, because it can have a minimum value of 0 only. Below that the value cannot be possible. Maybe there is a tower of height 4 or a tower of height 0, whatever it is, the height of this it will be greater than -1, so it will obviously be coming into picture for the first time. And also in the first tower and the last tower there is always 0 units of water. That is the reason. So yeah, so if the height is more, so I will update my L max to the current bar at star, height of the bar at star. And similarly I'll do the same thing. If height of end is less than, sorry, if it is greater than right max, then what I'll do is I'll update my right max to height of end. Cool. After that I need to check which one is greater, left max or right max. Based on that I'll be adding, like which one is smaller I need to find out, and whichever will be smaller, that variable will be decremented or incremented, and based on that only I will be adding things to my answer, okay? So basically I'll check if my left max is less than right max, for example, then what I should do is I should increment my left. But before that what I should do is for a particular element I should add certain how much water will be trapped above it. So that would be how much water should be trapped is, so the minimum is obviously L max. So L max minus it will be the height of that current building, height of I, okay? So after that I'll increment my left because left is smaller. After that, else if right max is greater, then with my answer I will add what, right max minus of height of j, because right max was smaller, so up till that level only it is the maximum allowed level. And I will also need to decrement the height of the tower, and with that I will do right plus plus as well. Sorry, right will be minus minus, right? And by the end of this, whenever my start and end will both face each other or they will cross each other, at that point I should just come out of this while loop and return whatever is the value in my answer. Did I make an answer? No, I did not make an answer. And answer should be equals to initialized with 0. Cool guys? Okay, so the internet is down. See, I'm running the code. So what what is the error? Height of I. Okay, I is not there, so basically you have to do height of the current start is right, because this is of when Lmax is minimum, and when Rmax is minimum, then you have to do height of end. Okay, left plus plus, what is the problem? Can I find symbol? Okay, so this is start and end, right? Start should be plus plus and end should be minus minus. Cool, guys? Okay, so this solution will be beating 100% because this is the fastest. Yes, so it depends upon a lot of scenarios. I've run the same code twice, I've submitted it twice, and the second time it became 100%. So this is basically we're doing it in one iteration. Start will start from the starting and end will start from the end, and until they cross. So basically it is covering one complete iteration, and also we are not taking any array as of that. As of we are just taking 4 variables, whatever the size of the array is. We are taking these 5-6 variables, and within that only we are doing it, right? So it is constant space as well. So yeah, that is the fastest solution. Thank you, guys.